is what we call IBM Big Data Platform. Though they are individually, they are sold as independent components. It's not one from a sales play, but it is more from how integrated they work with each other. Okay, so that was a brief, or rather a little more than a brief, about the big data platform. Now I want to get into some of the reusable components that were built, which will help you develop your applications faster, which we bundle with a big data platform. So there are 2 or 3 types I can call it. So one is which are very specific to applications or domains, and the other ones are much lower level. They may or may not be qualified to be called accelerator, but for the lack of better word, I just call it. One is, say, text analytics. And so I mentioned already that dealing with raw text. For example, if you look at the example here, right? It is some snippet from one of the sports news site. It says there is a football World Cup and a team distinguished themselves, losing to eventual champions and so on. So there are references of countries. There are references of things like striker, which is a role. It's like, in Indian context, you can think of like a batsman or a wicketkeeper and so on. And then there are references to people, and then there are references to the game itself. Right? And so how do I really figure out what is what? If I have to give it to a machine, I have to give it some structure. Right? So if you look at the classification below, all the names have to be in one column, all positions or the people have to be in other, and based on the country, and you can just keep on adding whatever you want. For example, you take maybe financial statements. There will be so many things. There will be talks about competition. There will be talk about the products people are, a company is manufacturing. There will be talk about the profits and losses. There will be talks about acquisitions, mergers, and various divisions, how they are working, right? And of course, the money is being spoken about. So, how, if I want to do any analysis on top of it, I want to automate all those things, I have to have capabilities to extract these things. Right? Now, I'm stressing more on the text analytics because most of the stuff I'm going to talk next heavily relies on the text analytics. Okay? So, how have we been doing text analytics in the past? Traditionally, is people have built various things on regular expressions. With you write a lot of rules and to identify various things with regular expressions and dictionaries, and so you apply a rule and it applies the regular expression, goes, finds it, and sometimes it says, oh, this is not matching. Now let me see the rule 2 fires and rule 3 fires and so on. Now this is a highly CPU intensive operation, and because we are doing this backtracking and going back and forth, it's extremely time consuming, right? So and you have to build everything from scratch. So where we came up with was a radically different approach to text analytics, and this was based on how we're dealing with databases, how we have relational algebra, which simplified the whole database technology and helped us build a whole set of optimizers, so that as a developer, I need not worry about writing the optimal code. I write it at a higher level declarative way, and the system does all the optimization that is needed. Right? That was possible because there was a whole notion of relational algebra. It was based on that mathematical model. So we applied the same relational algebra to text analytics, and the result is we have a system which is 20 to 40 times faster than the best text analytics applications that were available at the time we built it. And even today, this is the fastest text analytics. And more than anything, from a skilling point of view, those who know SQL can just pick this up because it is based on the same relational algebra and same kind of constructs, right? Things like select clause, projection clause, where clause, predicates, the same sort of things are applicable. So that way people can pick up these things quickly. And we provide all the basic constructs like parts of speech tagging, things like sentiment, all those things come out of the box. So one need not sit and do all those things. And of course, extracting all these things. And there's a language that comes with it. Similar to SQL, we call it equivalent. Now, based on, this is one of the foundational things for us, right, the text analytics. Now, so I was talking about the financial reporting and other things. Right? So we have some things in the space of financial analytics. One is based on the stream computing. It is how fast can I analyze the stock trades to figure out whether something is going up or down. And we have some toolkits called time series toolkits, which will look at the excuse me, look at the pattern of things like in a sine form or whatever waveform that it is coming in, and then I want to analyze and see if there is a pattern here, if there is an anomaly here. So a lot of those things have gone into the financial analytics. And then we have specific accelerators meant for the telcos. We have handled some of the biggest telco volumes. For example, just in India, we have some telcos who are having call detail records, or the CTRs, in the range of 6 billion per day. And they're having big challenges in terms of how they can analyze them and figure out how many priority customers calls are dropping, how many by maybe things like calls to which country are not really going through, getting cut or whatever. Right? And I want to do it in real time when billion people are talking simultaneously. So those assets has we have put it as part of the product now, and anybody who's interested in taking it further and customizing it can take that. And of course, there are the topic of today, which is social data analytics and machine data analytics. I will talk more about that in the upcoming slides. So getting into social data analytics.